Okay, so this is another episode of my Forge Diaries, and I want to show this tool that I've made. You can see it sitting here on top of my anvil. I've been working on the geometry of the shinogi-zukuri katana, and this is just a piece of scrap metal that I've been hammering on just to try to learn how to do it. It's quite challenging. So in a shinogi-zukuri katana, there's a bunch of geometry that's in this. Let's say that the blade is 1.5 inches thickness here. Then from handle to tip you expect it to taper from about 1.5 inches to 1.25 inches. So you got this taper. It's also supposed to taper in thickness from approximately 3/8 of an inch to about 1/4 of an inch. Then there's this groove that runs down, or pardon me, this ridge that runs down the middle of the blade, and it runs at about the 1/3 mark. So if it's 1.5 inches here, the groove is at, pardon me, the ridge is at 1/2 inch from the top of the blade, and it's 1 inch from the cutting edge. And then it should remain exactly proportional at 1/3. So while this blade gets narrower and narrower this way, this line does not remain at the 1/2 inch point. It actually remains at the geometrically 1/3 point. So this distance is less than 1/2 inch at the tip than it is at the, anyway, on and on. There's all this geometry that's built into this shinogi-zukuri style blade, and I've made several of these. It's just a piece of scrap metal that I'm just working on doing the geometry, and so far they all look like junk. Anyway, I got thinking, could I make a tool that would make this process easier? And this is the tool I've come up with. I got the idea for this from a blacksmith by the name of Niels Provos, who lives in Southern California. He's Scandinavian. I've ground into the surface of this a 7.5 degree angle on the upper and a 7.5 degree angle on the lower. Then I have a second one of these tools right here, and I've ground into it right there. I've ground into this one a 4 degrees on the upper and 4 degrees on the lower. Pardon me, 3.5 degrees. Well, it turns out that the angle on this crest needs to be 11 degrees. So I've built in both of the bevels for this. I can now take an ordinary piece of metal and I can insert it between these two dies, and I can pound on the top of this with my hammer, and I can hammer then into that piece of metal exactly the bevel that needs to be in the katana. And then once I've done, I can run through it a few times with this edge. I put the metal in and pound, 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 pound. Then I can switch it out. I can take this out and put this one in, and I'll turn the blade over and I'll do the back side. Pound, 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 pound. And it should build into the blade exactly the correct taper and exactly the correct angulation. I still have to use good sense so that I put the crest at the 1/3 level, so it's 1/3 the way, 1/3 the thickness of the blade from spine to cutting edge is where that line needs to run. So I still need to use, it doesn't make the process automatic, but it does make it much, much easier. Anyway, I have not used these yet. The reason I know it makes the process easier is because everybody says so. Niels Provos, I've seen his demonstrations of how these work, and they do make the process much easier. So I'm looking forward to using my spring instruments to see if I can make the katana making process a little bit faster. So one other thing I wanted to show was something I'm going to make into an anvil. I was at the scrapyard and just digging around for scrap metal, and I came across this thing, and I found 4 of these. These are 15.5 inches in diameter, 3 inches thick, and weigh 153 pounds. They are high quality steel. It rings like a bell when you touch it with another piece of metal. It's high quality steel, and it's just absolutely laser flat across the top and bottom. So, a 150 pound solid steel anvil is $700 to $1,000. This thing is going to make an amazing anvil. Part of the reason is this. If you look at the surface available on a regular anvil, for pounding, it's really, for my purposes, it's only this bit right here. It's about 3.5 inches by 4 inches. This bit over here has the hardy hole in it and is not useful for pounding and flattening steel. And the horn is for bending and twisting things. But really, it's only this bit right here which is good for as a flat surface for pounding with my hammer. And that is not so great. It makes it so that, you know, the metal tends to lean over the edge and bend this way and bend that way. And so for creating perfectly flat and perfectly straight pieces of metal, this little piece of anvil, which is all I've got, is not terribly useful. Whereas with this, I have a flat surface that is 15.5 inches in every dimension. So this is going to be an excellent surface for flattening and straightening sword blades on. So I need to build a pedestal for it like that, and I need to make the pedestal, you know, maybe that high so that the surface of that is the same height as the surface of this anvil. So I need to make my pedestal a bit taller. But I'm going to turn that into an anvil. So anyway, more on that later.